In this lecture, we will learn data types and data structure. First of all, what is the difference between data type and data structure? We can simply differentiate between data type is a kind of data that can be used in a programming language, and data structures are a kind of organized way of those data types that we can use in that specific programming. In Python, there are multiple data types that we can use, like numeric data types. In numeric data types, there are different data types like integer, floating point, and complex numbers. Let's see an example. Integer can be any number from negative to positive, and it should be a whole number. As we can see that 42 is an integer number, and when we check the type of that variable, that shows us this belongs to integer class. Same with the floating point. We can store floating point and use floating point numbers also. And here is a complex type that means a number with a real or imaginary part, like 3 plus 4j, it becomes the type complex. So we need to remember that we can only do the arithmetic operation or can combine the same type of data. Like in that case, we can see 3 plus 4j, it is a complex type. But if I try to do like integer and I try to add string value into it, it will give me an error like that. But for same thing, if I try to do that with numeric numbers, it will simply add the number, or if I try with the strings, it will concatenate that with each other. The other part is the sequence types. The sequence type is a string. Once it is declared and assigned in the memory, it cannot be changed. The variable can change its value, but it will become the copy of that same value into the new place in the memory, not the actual value is changed. Like if I save string in this variable, like string variable, and I wanted to change that, I can change that the same variable, but in memory, it will create a copy, but not change the actual value. So as you can see, we have a string value type str, the list that is mutable. That means any value that I will change here will be changed in the memory itself. And the tuples, immutable. There is another type that is mapping type. It's a data structure, and we can save key value pairs in this. As we can see that the name contains the value my name and gender contains the gender, and we can use these dictionary types with the mapping, and these indexes can be used to get the value, whatever the value that index contains. There are sets that we can create. These are mutable types, and this can be considered as unordered collections of unique items. Remember that sets can only contain unique items. So whenever we are defining a set, all values should be unique, or if we put the values those are not unique, ultimately set will only keep the unique values. A frozen set, that is an immutable version of set. Boolean type, true and false. Many of the programming language support Boolean type, and it is same all across the programming language. So we have learned the data types and data structures, and the difference between data type and data structures, mutable and immutable data types and data structures. Why we need data structures specifically? Data structures come with a bit more flexibility. Like if we have a list data type and we wanted to perform certain actions, language provide us default functions that can be used to make certain operation. Like if I have a list and I wanted to sort that list into a specific order, descending order or ascending order, so there are default functions that can be used to do that. In this case, I have list sort, and it can sort the list into ascending order. Now I can see that the lowest number is on the first place, and the highest is on the last place. And for further details, if you are interested to learn more about data structures and what kind of default functions available with the data structure, we can simply go to the Python documentation, and there are number of functions. Those are default available for those kind of data structure. We just use the one sort. It has multiple options that we can use also to ascending and descending, and there are examples also available how we can use them. So that's all for this lecture. See you in the next lecture.